Thank you. So today I'm going to be talking about differences between term and preterm children in attention and functional connectivity. And so I'm first going to orient you to what typical gestational development looks like in utero. So typical development takes about 40 weeks, and during this time there are rapid increases in brain volume and cortical folding. And these changes are paralleled by increases in functional connectivity strength and also the development of early brain networks. Now, very preterm birth occurs prior to 32 weeks, and brain development must continue ex utero in the stress of the neonatal intensive care unit. Survival rates for these preterm infants have increased over the years. However, long-term neurodevelopmental outcomes have remained poor. Specifically, preterm children are at increased risk for developing attention deficit hyperactivity disorder at some point in their lives, and this risk increases with earlier gestational age. Research suggests that in the neonatal period after birth, very preterm children have reduced functional connectivity compared to term neonates, even at 40 weeks. And however, it is unclear to the extent that these functional connectivity differences persist throughout development and how they impact the development of attentional control. So in order to answer these questions, we use data from a prospective cohort study collected in Christchurch, New Zealand. And in this study, children were followed longitudinally since birth, and for this study I'm using 58 preterm children and 64 term children. And we were specifically interested in childhood outcomes at age 12, in which ADHD, attentional control, and fMRI were assessed. Now, in this cohort, more preterm children did develop ADHD by age 12 than term children. However, we are interested more in dimensional measures of attention, so that's what I'm going to be focusing on for this talk. To dimensionally measure attention, we use the test of everyday attention for children, and this is a spaceship-themed attention task which uses various auditory and visual stimuli to index several dimensions of attention. Now, this is many different dimensions of attention, and for parts of this talk, I'm only going to focus on the last two, which are the more cognitively demanding of them, and this is shifting and divided attention, which is thought to index attentional control. So across attention domains, preterm children did perform poorer, but the greatest degree of deficit is observed in the attentional control domains of shifting and divided attention. So there are behavioral deficits in childhood at age 12, but how do these relate to brain development? So to index brain development, resting state functional connectivity was estimated. 10 to 25 minutes of data was collected per subject, and 5 minutes of clean, motion-free data was required for a child to be included in the study. And we weren't just interested in resting state functional connectivity, we were interested in the brain networks that you can estimate from resting state functional connectivity. And we specifically hypothesized that several brain networks would differ between term and preterm children. Specifically, we thought that the frontoparietal network would differ, the dorsal attention network would differ, the singular percular network, the salience network, and the ventral attention network. Each of these has distinct functions involved in attention, and we thought that these would be disrupted by preterm birth. So in order to determine network-level differences between term and preterm children, we estimated functional connectivity between every pair of ROIs, and we used this to form a connectome for both the term and preterm childhood groups. And then we took individual connectomes for each subject and correlated that with their individual variability on each of the 5 attention subtests. And this produced 5 connectome behavior correlation matrices per group. And we were specifically interested in these patterns, these clusterings within networks. So to assess the significance of that network association with attention, we permuted the subject-level behavioral data and correlated this permuted data with the connectome data 10,000 times. And this produced a null distribution in which then we compared the observed association to the permuted distribution, and we established network-level significance. So given this network-level significance, ability to assess network-level significance, we first wanted to ask the question, which networks are utilized across attention domains? So within the term group, term children tended to rely on the frontoparietal network in 3 out of 5 attention domains. They also utilized several other networks which we had hypothesized, including the singular opercular network, the salience network, and the dorsal attention network. Very preterm children, however, showed a very different pattern of networks that they tended to use with attention. And specifically, in 3 out of 5 attention domains, they utilized the ventral attention network. They also tended to rely on subcortical networks, including the basal ganglia and the thalamus. So we're seeing pretty different patterns of within-group networks supporting attentional control, but we then wanted to ask which networks differ between the two groups across all of these attention domains. So here the colors are showing the networks which were associated with a particular attention domain, and each of these significantly differed between the two groups. This is a lot of data, and for the sake of time, I'm only going to focus on those two attentional control domains of shifting and divided attention. So for shifting attention, very preterm children showed reduced associations between thalamovisual connectivity and shifting attention, and this is associated with poor shifting attentional scores. In contrast, very preterm children demonstrated stronger ventral attention and visual network connectivity associated with divided attention. And these negative lines indicate that this is a negative correlation. So children with the greatest ventral attention to visual connectivity actually had the worst divided attention scores. Similarly, very preterm children relied more on thalamus auditory connectivity than term children did. However, these red lines indicate a positive relationship, meaning that children with a greater thalamus auditory connectivity actually had better outcomes. So this could be a potential compensatory mechanism in this preterm group. So in summary, very preterm children performed worse across attention domains. And the highest level of deficits were observed in intentional control, specifically shifting and divided attention were impaired. Term children demonstrated hypothesized functional pathways supporting typical development in those networks, including the frontoparietal network and dorsal attention network. In contrast, very preterm children demonstrated an unusual and aberrant pattern of connectivity associated with poor attention control in childhood. And specifically, we observed attention associations in ventral attention network, thalamus and subcortex, and sensory networks. Our prior work has demonstrated reduced thalamus connectivity at birth, and we've also shown reduced thalamus cortical processing in childhood, and this has been associated with poor outcome. And I think this is consistent with what we're seeing here with poor sensory thalamus processing and attention. I'd also like to point out that in the same preterm cohort, previously volumetric analyses had demonstrated that their very preterm children had reduced thalamus volume and greater visual cortex volume than term children. And I think this mirrors the findings that we're seeing here in functional connectivity. And these convergent results are suggesting aberrant thalamosensory processing in preterm birth. So in conclusion, I believe that there are persisting developmental long-term impacts of preterm birth, and this affects attention outcomes and also functional connectivity throughout development. We observed altered but potentially compensatory brain networks, which may support a degree of attentional abilities in preterm children. And I do think it's important to understand the network basis for behavior, and I think that network-based analyses can inform potential treatments or interventions. So with that, I'd like to thank the families and children who participated in this research. I'd like to thank my collaborators and the funding which made this research possible. Thank you.